Alright, in this last video I wanted to go into a bit more detail on how to actually use PGMcpp. So we'll do a bit of a deeper dive into the Python example script that's provided. So if we open up the source code folder here, go into projects, and we'll open up this example Python script. Alright, and then at the same time I want to be doing side by side with the documentation. So PM docs, there we go. Alright, so I know we're looking at this. Alright, so how to actually use PGMcpp from Python. If we start walking through the script, the first thing you'll notice here is this system path insert command. So this is just pointing to where our pre-compiled bindings presently are. So if we're running this from the projects folder, what this is saying is go up one directory and then go into py bindings and pre-compiled bindings, and then we can find our bindings are here, these ones. Right. So if you want to maintain a single copy of the bindings somewhere else in your system, you can definitely do that. You just need to modify this line to point to wherever it is. And then importing PGMcpp is what actually gives us access to the functionality of this program. Alright, so the first thing we're doing here is we're constructing a model object. So if you're going to use PGMcpp, you need to create a model. Every object in PGMcpp has its own input structure. So here it's just a model input structure. And the attributes we're changing in this example is we are passing in a path to an electrical load time series dataset, and we're also setting the dispatch control mode to cycle charging. So the path that we're using is this path here, which we're just grabbing the example electrical load data. So if I go to where that is, it'll be in data, test, electrical load. So it's this example electrical load time series that we're pulling in. So if I just open it with a simple text editor, this side. Of course you can open this in Excel as well, I just don't have it installed right now. This gives you an example of the expected format for electrical load input. So we've got a column which gives us the date time, and we've got a column which gives us the number of hours since the start time, and then the third column is just the electrical load in kilowatts. Time series in PGMcpp can be of any length, and they don't have to be uniform time series, so the delta in between the points in time can vary. The only constraint is once you read in an electrical load time series, every other time series you read into the program is expected to be of the same length and for the same points in time. So every other time series we use after the electrical load has to line up with this time series. So that's what this block of code here does. It sets up our model instance and defines the time series of electrical load or electrical demand. Next, we're going to try adding some diesel generators to our model, so that's what we're doing here. And if anything's unclear, we can always refer to the documentation. So let's use this as an example of looking at the documentation. So we're going to start with defining a diesel input structure. But if it's not clear what's actually in the diesel input structure, then if we go to the class documentation, we should be able to find the diesel input structure. Yeah, so here's the diesel input structure reference, and it's all laid out in the documentation here. So the attributes that are available in the diesel input structure is this list of attributes here. So each one has a data type, it has a name, it has a default value, and then a short description here. So you'll notice that there are many more attributes available for diesel inputs than are actually used here. Like we're really only changing the value of two attributes. We're changing the capacity attribute, which, as you might expect, is what the actual rated capacity of the diesel generator is. And then here we're defining whether or not it's considered a sunk cost in the economics modeling. And the input structures will also contain the input structures from the parent classes. So this capacity kilowatts is actually in production inputs. So if we go and look at production inputs, which is where, yeah, here, production inputs. So these are the attributes that are available in production inputs. All right, so It's just showing the class inheritance that's in play here. Actually, if I go back to the diesel input structure, it'll show you here, right? Diesel inputs is a combustion inputs, which is a production inputs. So here we're adding, so we're creating a diesel input structure. We're saying, all right, we're going to add a 300 kilowatt diesel generator. We want to treat it as a sunk cost, and then we're adding that to our model. And then here we want to add two 150 kilowatt diesel generators. So we're reusing the same diesel input structure. We're changing the capacity to 150, and then we're just adding two of those to our model. So right now our model has a 300 kilowatt diesel generator and two 150 kilowatt diesel generators. Next, we're going to add some renewable resource time series to our model. So if we want to be able to model the integration of renewable production assets like solar or tidal or wave or wind, for example, we need to have renewable resource time series for those. So here what we're doing is we're saying we're gonna define a solar resource key, because later on when we add the actual solar PV array, we need to associate it with a particular resource. So here we're saying the solar resource key is 0, and we're defining the path to the time series for the solar, in this case the global horizontal irradiance values. Then we're going to add that resource to our model. So here we're saying it's a solar resource, here's the path to the data, and here is the key we want associated with this particular resource series. So again, referring to documentation, if we go to the model class, because this is a method of the model class, or a member function of the model class, and we go to add resource. Here we're adding solar resource, so it's this method we want to look at. So we can just click on it, it'll take us right to it, and it gives you a description of what's going on, what inputs are expected, and what those inputs are. And it's the same structure for tidal. So here's an example of adding a tidal resource time series. Here's an example of adding a wave resource time series. And here's an example of adding a wind resource time series. So again, there's example time series of each of these data sets provided. So if I go into the test data, for here I'm looking at resources, for example, and then for wind, this is what a wind resource time series would look like. So essentially the same structure as the electrical load, it's just the header here has changed. Here it's wind speeds at hub height in meters per second. So again, use these example data sets as templates for setting up your models. All right, so that's adding resource time series. Yeah, here's the example for hydro, so we're adding a hydro flow time series. Next, this is a block that shows how to add a hydroelectric plant with a 300 kilowatt production capacity and a 10,000 cubic meter reservoir to the model. So again, a lot of this is the same pattern over and over again. We're creating a hydro input structure. Then we're modifying the attributes of the structure. So here we're setting the nameplate capacity, setting the reservoir capacity, setting the reservoir's initial state, defining whether or not we're considering this a sunk cost in the economics, and then finally passing in the hydro resource key to associate it with the right resource. So the hydro key that's going here is the same key that was defined here. So this just matches resource series with the assets that exploit that resource. And then finally, we're adding a hydroelectric asset to our model. And again, we can go back to the documentation. So here, let's say we want more details on what is actually available in this hydro input structure. Well, we go and look at the hydro input structure. Where is it? Here it is. Hydro input structure. Okay. So again, we can see here. We can see what the class inheritance hierarchy looks like, and then we can see which public attributes are available in the hydro input structure. And also we can look at the inherited structures. So here non-combustion inputs is inherited, so we have access to, well, this particular one doesn't have any attributes, but it inherits production inputs, and production inputs has a number of attributes that are useful to change. For example, the nameplate capacity, some economic parameters like inflation and discount rate, how many running hours should it be replaced after, and so on. All right, so now we want to add renewable production assets to our model. So here we're adding a 250 kilowatt solar array. So again, it's the same pattern. Create the appropriate input structure, modify the attributes of that structure as needed. In particular, don't forget to associate with a resource series, and then we add it to our model. For title, it's the same. Create the title input structure, modify the attributes of the structure as needed. Don't forget to associate it with a resource, and then add it to the model. Then the same for wind and wave. Finally, we'll add a lithium-ion battery energy storage system. So, not surprisingly, the same pattern. Create the appropriate input structure, modify the attributes of the structure, and then add that component to the model. Right? And then once you've created your model, adding whatever components you want, whatever resource series you want, the right electrical load, the last part is to just run the model. So this line will run the model, pretty straightforward. And then this line will write the model results to whatever folder you give it. So we're calling it example pi. So when we run this, what will happen is in our projects, when we run this example pi folder will be created in this directory, and all of the results will be written to that folder. Right? So that's walking through block by block the example script for setting up and running a model using the Python bindings. So now we'll actually do that. So if we go here, open up command prompt. So we're running from this location, which is important. So it's just Python example.py, and then we'll run. All right, so now it's done. So it has created our model, run the model, and written the results. So here are the results that come out. And for example, if we look in model, these are the highest level results, and we'll just look at the summary results, and we get the same summary results output as we got in the C++ example. So that's all of the model level, so the very high level results. You can also descend into particular components and read the component-wise results. So for example, let's say we're interested in what the wind is doing. So we'll look at the wind summary results. So these will be the summary results specifically for the 150 kilowatt wind turbine, or turbine array, whatever, that we had added to our model. So that gives some of the high level results for this particular asset. Or if we need more detail, it also gives us time series results. So if we open up the time series results, we have time since the start of the model, what the wind resource was in a particular time step, the production, the dispatch, the storage, how much was curtailed, etc., etc. You can see them in the column headers here. So this gives us a detailed record of what this particular asset was doing at every point in time in the model. And the same is true for every other asset. So ditto for tidal, ditto for solar, whatever you need, everything. Okay, that's actually, so walking through the script, actually running the script, and then maybe a little bit on the data would be good. So for the resources, there's the you see the examples here, and some of them are flagged bad, so these are just used for testing. But if you wanted to, say, add a wave energy converter, this will give you an example of what it's expecting for input. So it's a time series of significant wave height and energy period. And again, these time series can be as long as you want, as long as they align with the electrical load time series. I don't think there's much else to talk about. For more details, you can always refer to the documentation here. So that was a look through the example, the Python example script. So to give you an idea of how to go about setting up and running a PGMcpp model using the Python bindings that we compiled in the previous video.